Well, good morning to you. Let's keep moving. So the plan, this is not the plan. 12.2 will be due on Wednesday for you all, right? Wednesday, and these are later. All right, so 12.2. Plan is to finish 12.2 today and get a good running start on 12.3. All right, so 12.2. Here we go. So 10th term is 0, and the 60th term is negative 100. So let me write that up here. So the 10th term is 0, and I'll do it in a different color here. 60th term, negative 100. Okay. So, how do we do it? Remember what we do? What formula are we using? A sub n. Now, I'll give you this formula right at the top of the next test. A sub n is A1 plus n minus 1d. Right. So I will give you that formula right at the start of the next test. Right at the top, plus 4 other formulas, which I'll show you as we go. So you don't have to put it on you don't even have to put it on your 3x5 card. It'll be right there for you. All right, so then we use that formula. We plug in the information they're giving us. 10th. Now, what is 10th? Here's where you're going to really want to know. Remember I said the ordinals are always in. This is in. Oh, and what do I mean by ordinal? Number like 10th as opposed to 10. When it has the th on the end, or the third, or fifth, or seventh, that implies an ordering, doesn't it? Those are called ordinals. And I don't care about the name, but you should know that's always in. Whenever they have a number like that, that's always in. So plug that in for n. So that means in there is 10. A sub 10 is A1 plus 10 minus 1 times d. Good so far? Just put in the 10 for n here and here. Now, what is A sub 10? What does that mean? A subscript 10. That means the 10th term. We're talking about a list of numbers, right? That's what these sequences are. A list of numbers with commas between them. And they're saying, hey, the 10th one in the list? Well, do I know what the 10th one in the list is? Yeah. The 10th term is 0, they're telling me. So that's 0. And 10 minus 1 is 9. We all good to there? So now, leave that. Now do the same thing for the purple one. The 60th term is negative 100. Plug in A sub n is A1 plus n minus 1d. So, an is A1 plus n minus 1d. 60th, that's your n. So everywhere you've got n, now you know it's a 60. And what is the A sub 60? What is the 60th term? They're telling me it's negative 100. And 60 minus 1, 59d. Good. So now we've got 2 equations that have 2 letters, A1 and D. So it's just like having 2 equations with x and y. We can solve for those 2 letters. And then we'll have the formula. Does that make sense how we're doing this? So just line them up side by side. Doesn't matter where. I'll just bring this one maybe over here. I'll just bring it on over. So 0 is A1 plus 9. Just line them up vertically. Now remember the easy way to solve these?
Make the bottom one negative.
Make the bottom one negative, or the top one. It doesn't really matter which one. Yeah, totally. Just run a negative sign through one of them, and then add them up. So negative 100 and negative 0 is just negative 100. A1 and negative A1 cancels. That's why that works so nicely. You drop out a letter. And then 59D minus 9D is 50D, because that's a minus now, because I did negative on that bottom equation, right? So 59 minus 9 is 50. And now I can solve that for D. Divide by 50. D is minus 2. So once you've got one of the 2 letters, how do you find the other one?
Oh, you plug it in.
Plug it in anywhere you want, pretty much. You can plug in this equation, that equation, either one. I'm just going to grab this maybe and put it in right there, just because that's the closest thing. A1 plus 9 times negative 2. A1 minus 18. Move it over. A1, I'm getting scribbly there. Jump it over. A1 is 18. So we got A1, we got D, we got all we need. So what do they want? They want you to say, give me A1, give me D. Now, let me explain this part right here. This part can be confusing for you. Here's A1 again. And then they say this. What they want there is the recursive formula. Now remember what the recursive, let me write it over here. Remember what the recursive formula, what does it mean? If you have a recurring dream, you just keep having the dream, same one you had before, right? So to recur means to go back to what happened before, doesn't it? So if something reoccurs, what happened before happens again. Well, therefore, whenever they ask you for a recursive formula, they're saying, look, we want a sub n, and on the other side, we want a sub n minus 1, and then some numbers. Because that's the previous term. That's what happened before. Right? You with me? A sub n means, you know, in any term, and n minus 1 means previous. Right? N minus 1, it's one term back. It's the previous term. Does that make sense? Whenever they ask you for a recursive formula, they don't just want n's and numbers. We'll do that one in a minute. That's right here. That's not, this one is not recursive. This is just the nth term formula. It just has numbers and letters, n and numbers. But the recursive formula has a sub n minus 1, the previous term. It's recurring, right? So, well, how do you know what to do? Well, you tell me. D being negative 2, what does that mean? That means the difference from term to term is negative 2, meaning this sequence is going down by 2, down by 2, down by 2, down by 2, from number to number. That's what the D means, the difference, the jump from number to number, right? So if the sequence is going down by 2 every time, then any term is the previous term down 2. Take away 2. So there's the recursive formula. Notice how the recursive formula is no good for jumping like a CD or a DVD, as I was talking about yesterday, right? If somebody asked me, I said, what's the 100th term? I don't know. I can't jump to the 100th term all of a sudden. Try it. Plug in 100. N is 100, right? 100th, that was an ordinal, so plug in for N. If I plugged in 100, it won't work. Well, it won't work well, because this will be 99. So what it's basically saying to me, whoops, that's A, I'm going too quick here. A 99 minus 2. It's saying to me, you want the 100th term? Take the 99th and subtract 2. Well, I don't know the 99th. Well, sorry, you're out of luck then. So the recursive formula only tells you one step at a time. It just recurs upon the last one, right? You'd have to, like the old cassette tapes, you'd have to go through everything. But it's still valuable for different kinds of things. So they want the recursive formula, there it is. And then finally, they want the nth term formula. So how do we come up with, I'm going to totally add room, I'm going to scribble this away here. How do I come up with like the nth term formula? Well, you know that's the a sub n thing, so let's do that up here. So I'll come up here and go, okay, a sub n, so this is the nth term formula, is a1 plus n minus 1d. That's one I'll give you right at the top of the test. That's one of the 5. A sub n then is a1. A1 means first term, right? First term. Oh yeah, here. It's right here. I'm thinking, well, I don't know what that is. It's 18. That's right, we found it. 18. And D, right here, negative 2. And then you just distribute, and you get AN is 18 minus 2N plus 2. And 18 plus 2, 20 minus 2N. And so that's how I got 20 minus 2N right there. So that I could jump to the 100th term right now. I can plug in 100 right there. 20 minus 2 times 100. 20 minus 200, negative 180. There it is. There's a 100th term that quick. Right? So you can jump anywhere. So this is a little bit more powerful, is the nth term formula. The recursive always has an minus 1 in it, because it recurs to the previous. And that's everything. We good on that one? I'll try one of those. Okay, so they're telling me, put it up here, they're telling me 13th term is negative 4, and they're telling me 18th term is negative 14. There they are. So try this with you. Write the two formulas. A sub n is a1 plus n minus 1d kind of thing, right? For both of them. Plug in your stuff for both of them. Right? Plug in what you can. Miss Erica, the lady soccer team. You guys ranked number one in the state? Is it number one in the nation? Number one in the nation. The ladies soccer team, Division III, number one in the nation. Playoffs start this Saturday, right? Yeah. 9:30 or so. The ladies in the other class were telling me 9:30 or something like that. Our field, obviously, we're hosting. We're that top high seed. All right, that's exciting. Congratulations. I can't remember. They're always done well the years I've been here, but I don't remember a number one ranking before. Yeah. That's pretty good.
You've been here that long, sir?
I've been here. This is my 11th year.
Yeah.
I've been teaching math 25 years. Been married for 26. I'm an old guy.
Yeah, I wasn't trying to.
I got kids older than you.
Yeah.
All right, plug all that stuff in. All right, so A sub n. Oh, we're plugging in. So plug in 13 for n. Or remember, the ordinal's always in, right? The 13th or whatever those kind of numbers are in, always in. So A sub 13 is A1 plus 13 minus 1 times D, and I don't know D. Like that? That good so far? And then A sub 13, what is A sub 13? What is the 13th term? Well, it's negative 4. It's 12D. That good for that one? Now do the purple one. Same kind of thing. So plug in 18, that's in again. And then A sub 18, the 18th term is negative 14. We get to there. We got those, and then just line them up vertically, one over the other, and get stuff to cancel.
Pretty easy.
Too bad. And then I would just run a negative sign, multiply the bottom one or top one, doesn't really matter which one, by negative, so this will be negative, negative, negative. And this one, two negatives make positive. And add them up. Negative 14 plus 4 is negative 10. The A1s cancel. And 5D. That good? Am I going too quick? Divide by the 5. Is that what we got last time? D is minus 2. They're all D minus 2 now. So D is minus 2 for this one as well. Now plug in to get A1. Take that up, put it in, so we get minus 4 is A1 plus 12 times D. D is minus 2, minus 4 is A1, minus 24. Add the 24, it's at 20. A1 is 20. So A1 is 20. So we got A1, we got D. You can answer all the rest of the questions, right? I'll just move on. There are other things we got to do. That good there? Questions on that one? Okay, so now I want you to notice the difference Notice we have plus signs between them now. So that's what's changing. There's plus signs now, not just commas. And so we're going to use a new formula, not the a sub n. So basically, if they listed them 7, 9, 11, whoops, kind of getting scribbly here, 7, 9, 11, ... 73, that would be a sub n formula. For these guys, we're going to use what's called an s sub n formula. I'm going to give you a new formula in just a second. It's an s sub n formula. Do you get the difference between those two? So a sub n is when there's commas, you're just listing them. It's like, what we normally have done. It's what we've done all the way up to here. But if you put plus signs between them, then it's S, which stands for sum. I'm going to give you a formula in a minute for adding them up. Let me, to do that, let me introduce, you guys ever heard of Carl Frederick Gauss? Probably the greatest mathematician of all time. It's debated. He's certainly considered one of the top 3 ever. Anyway, real quick, Carl Frederick Gauss, he was a 5 years old or something like that. He was correcting adding mistakes in his dad's bricklaying book. He had a book of, keeping record of the accounts, and he was correcting mistakes in there. Went off to the local school, small village in Germany, 1800s.
Had to be German.
What's that?
I knew he had to be German.
He had to be German? How'd you, Carl Frederick Gauss?
I just heard.
Sounds German, huh? All right. So anyway, the teacher, 3rd grade, 4th grade teacher said, hey, I want you kids to take your slates, those little chalkboard hand slate things they had, and add up the numbers 1 to 100. I mean, what a pain, right? I think the teacher was just trying to buy time, right? Just get them busy. Busy work, busy work. Leave me alone, right? That's what that teacher, 3rd grade teacher was doing, I think. So I took those, imagine that with a little slate, right? Got a little slate. You go, okay, 1 plus 2, that's 3. Okay, now add 3. 1 plus 2 plus 3, so okay, that's 6. Okay, now add 4. Okay, that's 10. Now add 5. That's 15. Okay, erase the slate. Start again. Where were we at? 15. Okay, well, last one was 5. Okay, now 6. Right, you see, that's a pain, right? All the way to 100. Add up all the numbers 1 to 100. So Carl Frederick goes the story. I think it's pretty well attested historically. Carl Frederick said, well, I don't want to do all that. Maybe what I could do, anybody know? What did he do?
He did the formula.
No, he came up with a formula. What did he do? He said, how about if I take that list of numbers and I just write them backwards, right underneath? What'll happen? A lot of math and science, a lot of discoveries in all kinds of fields are just by trying stuff. Just try something. See what happens. Remember Einstein's famous quote? For a scientist, imagination is more important than knowledge. He means you imagine. You just try something. See what happens. So what he did with the theory of relativity about the speed of sound, speed of light being the same relative to all objects. Who would have thought? Anyway, we're not doing a physics class. So Carl Frederick just laid these out and said, what if we just put them backwards and add them up? What'll happen? I'm just going to add these up. Straight up and down, vertically. 100 plus 1. 101. 99 plus 2. 101. That's interesting. 98 plus 3. It's 101 again. 98 plus 3. 101. 99 plus 2. 101. All right, that's cute and everything, so they're all 101. Oh, no, that's way more than cute. We're done. That's a genius discovery. What? How are we done? How many 101s are there? Right, everybody see that? Right, there's 1 in the 1 spot, there's 1 in the 2 spot, there's 1 in the 3 spot, all the way to 98, 99, 100. There's 100 101s. I can add up those 101s by multiplying. Now that's going to be twice the list though, because that's the list forward and backward. And we're just supposed to add it up one time, not twice, so divide that all by 2, right? To get the real answer. So let's do that. How do you multiply any number? Like how do you multiply 101 times 100? Add 2 zeros to the back. There's 101, add 2 zeros to the back, right? So that's 10,100. Divide by 2. What's half of 10,000?
5,000.
What's half of 100?
50.
50. We just added the numbers 1 to 100 that quick. The story goes, I'm not sure how reliable this part is, he brought it up to the teacher within minutes, real quick. Everybody else is working on their slates, and Carl Frederick comes up there, 50-50, and the teacher got angry and accused him of cheating and sent him to the back of the room. So he was just a little too smart for that. He was too smart for everybody, basically. He continued to do great things in his little village, and his dad wanted him to take over the bricklaying business. But that would have been a crazy loss to society. So instead, the villagers got together some money and sent Carl Frederick off to the Germany university, and Carl Frederick quickly was smarter than his professors. That'd be like if he was taking this class and he was constantly showing me better ways, quicker ways to do the problems, deeper insights. That's what he did when he showed up. He was just ahead of his professors right away. Quickly became a professor there, and the rest is history. Carl Frederick figured things out so fast that he would publish. His publishing mantra was few but ripe. And he wasn't just trying to be prideful. It was just wise given how fast he discovered things. Meaning, he didn't publish every little tiny thing he discovered. He didn't have time to. He would only just publish the big ones. And so like a lot of times his colleagues would come to him and say, hey, I discovered such and such in physics or astronomy or math or something. And Carl Frederick would go, oh, yeah. He'd look back and I found that out a couple years ago. That's a good one. You go ahead and publish that. I didn't have time for that. Because he just would do the big ones. He would discover stuff so fast. The big ones. Yeah, when I took Physics 4B, that was the hardest thing I did at junior college. I don't know if you're headed that way. But you got to do calculus first, and then this is calc-based physics. Then you take this physics class using calculus. Really tough stuff. Physics 4B was the electromagnetism one. Anyway, in that course we had 4 formulas that kind of the whole class was built around. Carl Frederick had 2 of them. 2 of them were his babies. He discovered them. Anyway, and he's discovered things in statistics, astronomy, all kinds of, just genius guy. All right, so with that in mind, let's do Carl Frederick's little method right here on this problem. How could I do Carl Frederick's little method? Well, if I reverse the numbers, right, 73, what's the one right before 73?
72.
No, 71.
Yeah, because they're going up by 2 every time, so it must be 71, 69,
You said right
7,
before, not
like that. And then add them up. What are you going to get? What's going to happen? Add these 2 up. That'd be 80. Add these 2 up. 80. Add these 2 up. 80. They're all 80s. How many 80s? Well, that's a little more tricky now. We don't know how many. At this point, let me just give you the formula. Well, let's just say there's n terms. We don't know what n is. There's n terms. How would you figure out what they all add up to be? You would take 80 times n, right? There's n 80s. And you would divide by 2 because that's the list twice, forward and backwards, right? Where'd that 80 come from? Let me put it back this way. N times 80 over 2. And what did that 80 come from?
That's what they add up the total.
Here and here, which is what? The first term, A1, and the last term, which we call A sub n. So in other words, it's A1 plus AN. It's first term plus last term that makes the 80. So it's n 80s over 2. And there it is. There's the formula. So I just derived. I never get to do that in here. Never have time. I took time today. So I just derived a formula. There is the S sub n formula. That's the one we're going to use. Now, you don't have to know all that or follow all that. You just have to be able to use it. I'll show you how to use it. I'll give it to you right at the top of the next test, along with the A sub n formula, and actually 3 other ones we'll get the next couple of days. The A sub n one is A1 plus n minus 1d. I'll give you both these at the top of the next exam. Don't even have to put them on your card. They'll be at the top of the exam. So anyway, this one, A sub n, is for the commas, remember? And this is for the plus signs, because this is S sub n, sum, adding them up. All right, so with all that in mind, let's solve this problem finally. So, all right, so here we go. 7, 9, 11, all the way to 7, 3. We want to add them all up. We'll use the Carl Frederick formula. N over 2 times A1 plus AN. Right, there it is, right? First term, see what that is again? First term and last term, huh? First term and last, which is what you do when you reverse the list, times n terms, cut it in half because that's the list twice. So, first term, last term. And what is n? Number of terms. So the main thing is knowing what these letters represent. N is the number of terms. A1's the first term. AN's the last term. Like that? All right, here we go. So what's the number of terms? I have no idea. Let's go to the rest of the stuff. A1, what's the first term?
7.
Yeah, that's 7. What's the last term?
73.
73. That's A sub n. So we know that. We still don't know n. We don't know the number of terms that are there. We're going to have to get it. Where can we get it? we use the other formula. So this is a little bit of a challenging problem. Some of the other ones will actually be easier. We have to use the a sub n formula now, the other one, to find n, because I don't have n here. So you see what I'm doing? I'm going off to the side using the other formula, do a bunch of work, find n, bring it back, plug it in. All right, so here we go. 73 is a1, 7, plus n minus 1 times d. What's the d? The difference from term to term? Adding 2 every time. Distribute this. 73 is 7 plus 2n minus 2. 73 is 5 plus 2n. We good? So far, so good? Solve for n. Subtract 5. What's that? 68 is 2n divided by 2.
34.
N is 34. Grab that and pop it in. 34 over 2, add these up, 80. And whatever that calculator tells you, that's your answer, 1360. So all those numbers must add to be 1360. Is that good? So we use the S sub n. Whenever you got plus signs, you think, I need the S sub n. It's going to be the same thing in the next section. So you want to get that principle down. We're going to have an A sub n and an S sub n in the next section as well. So anytime you have plus signs, that's the S sub n. You write that down, start working with it. Realize you need n, so you break aside, use the A sub n, get n, bring it back, finish up. Good? Questions on that one? All right, here we go. 6 plus 13 plus 20, plus 111. All right. Try that one. So they have plus signs, so use the S sub n, the sum formula. So remember what these different pieces represent. N is the number of terms. A1 is first term. AN is last term. First term is 6, last term is 111. So to find the n, got to go over here, use the A sub n formula, right? So plug in. A sub n again means last. Remember, whenever you see A sub n, it's last. A1 is first. And so last term, 111, is A1 first term. And D, what's the D here?
7.
So it's adding 7 every time, huh? Like that. Boom, boom. 7n minus 7. 6 minus 7, negative 1 plus 7n. Add 1 to both. 112 is 7n divided by 7. What's in? 16. Thank you. Bring that back. Oops. What just happened? I said bring that back. There we go. So plug in the 16 then. 16 over 2, whatever this is, 117. 8 times 117. 936. Well, we got it. Did we get it? We good? Questions I can answer? All's well? All right, I'll keep moving. Stop me if you want to. All right, so the sum from n equals 1 to 60, 3n minus 6. All right, so what does that big symbol mean? Yeah, I just said it, huh? The sum. Yeah, it means the sum. We've had it before, huh? It's a big Greek S. Sigma is what it's called. Anyway, so sum. So it means the sum, meaning take that formula, 3n minus 6, plug in 1, plug in 2, plug in 3, all the way to 60, huh? This is where you start, and this is where you n, and you plug in for n to the formula right there, huh? Remember that? We've done it before? So we say, okay, 3n minus 6, well, here, let me just do it this way. Plug in n equals 1. So if you plug in n equals 1, what do you get? 3 times 1 minus 6, negative 3. Plug in 2, what do you get? 3 times 2 minus 6, which is 0. Plug in 3, what do you get? 3 times 3 minus 6, which is 3. And then you're going to put plus signs. Why? Because that's what the Greek S means. You're summing them. You're adding them up. Plus, dot, 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 all the way to the last one. The last one is 60. N is 60. Plug in 60. So 180 minus 6, 174. Dot, dot, dot. Like that. So that's what it's really saying. Start at negative 3, go up by 3 every time, all the way to 174. Add them all up, tell me what you get. So there's plus signs, so which formula am I going to use? S sub n. Makes sense. Big Greek S, going to use the English S. S sub n. N over 2, A1 plus AN. All right, what's n?
Don't know.
Usually we don't know.
Oh, it's 60.
But here we know. Isn't that nice? This will be easier. We know n. No mystery how many terms. Started at 1, ended at 60. There's 60 terms. So that's nice. We're not going to have to use the other formula. A1 always means first term. AN always means last term. And n again was number of terms. So first term, negative 3. Last term, 174. First term, last term. Everybody good there? So it's 30 times 171, so whatever that is our total. 5130. And there we go. A little easier actually than the other way, huh? Because we know how many terms right away. Only had to use one formula, just S sub n. Good on that? Questions I can answer?
A lot of those on the test, right?
Certainly one. One exactly like that, probably.
Yeah, that's a no.
Yeah, we're never going back. I never have time. It's the story of my life. All right, find the sum of the first 120 terms. All right, so this is a little different. Let me see what you can figure out on this one. Now, it says sum. Even though there's only commas, they are saying the word sum, so we're definitely going to use the S sub n formula. Like that. Okay. See what you can do there. So they're coming at you a little different here. Remember let me give you what the terms are. N is the number of terms, A1 is first term, AN is last term. So plug in what you can there.
Oh, I just plugged that. Oh, okay. It's pretty easy.
Do we know what N is? Do we know what the number of terms is? 120, huh? So that's 120. Good so far.
17 is A1.
First term is, yeah, clearly 17. Good job.
What the last term is.
But we don't know what the last term
goes
is.
into the other formula.
Good job. Go for the other formula. Yeah, we don't know A sub n, so let's go use the A sub n formula. Exactly. See that? We know everything but A sub n. So use the A sub n formula to actually find A sub n, and then bring it back and finish up. Am I making sense? These are the different looks they can give you on this. So A1, first term, 17. N, we already know N. N is number of terms, right? That's 120. That's N. And D, what's the D? What's the difference from term to term?
Positive.
2, huh? What's that, 238? And then add that up. 255. Good there? We doing well? Say A sub n is 255. Take that, bring it back. Is that 272 there? I think, and 60 times 272. 16,320. There we go. That good? So a little slight alteration from the last one. So we just always start with the S sub n formula. See what we need, go get, if we need the other one, we use it.
And then we do it the opposite. Do we do it differently if they give us the last one? Then we could do it.
Yeah. Then we don't know n, and yeah, so it depends how they give us information. Yeah. Sure. These last few are, well, some of them are valuable, some of them are tricky. This is a tricky one. Okay, so they're basically saying, all right, x plus 2 is the first one. 5x plus 3 is like this. So it's the first, the second, they're just doing it with an x. And 4x plus 1, that's the third term, and on they go. It's an arithmetic sequence, find x. Now that's like really different. Like what? You know, why are they doing this x stuff, and how can I find x? Well, we don't got time for me to quiz you and play games here. Think about an arithmetic sequence. Let me do one that's adding 4 every time. So add 4, add 4, add 4, on you go. So if it's, and they said it's arithmetic, if it's arithmetic means arithmetic, meaning adding or subtracting, right? That's arithmetic, the same number every time. So if you're adding 4 every time or adding whatever, that means from here to here, whatever's being added is the same thing that's being added from there to there. That means the difference, the d, from term to term, has to be equal. So in other words, I take second term minus first term. That's the difference between the second term and the first term. That must be equal to the difference between the third and second, because it's the same jump every time. It's the same difference. That's the trick you got to do. You got to take the second formula, this one, 5x plus 3, minus the first one, this one, x plus 2. And that's equal to the third one, that one, plus minus the second one again. Those have to be equal, because it's the same jump amount. It's the same difference between the first and second as it is between the second and third. Do you all see that trick? That's the trick. Then you got to solve that for x. So distribute the minus sign. 5x plus 3 minus x minus 2. Distribute the minus sign. Minus 5x minus 3. Gather like terms. 5x minus x is 4x. 3 minus 2 is 1. 4x minus 5x is minus x. Plus 1 minus 3 is minus 2. Like that. So bring it up here. 4x plus 1 equals minus x minus 2. So now finish solving for x there. So add x to both. 5x plus 1 is minus 2. Subtract 1. 5x is minus 3 divided by 5. There's x.
Why couldn't we just do the second? I don't know why, but I just used the second number.
Second number. What's the second number?
of 2.
Oh, the second term? 5x plus 3?
I just minus 3 and divided by 5. Because it's supposed to equal, you said they're supposed to equal the difference. So
tell me exactly what you done. So you took 5x plus 3, and what'd you do with it?
I made it equal to 0.
Why would it be equal to 0?
The first one doesn't count as a of 1, so I just skipped to that one, and that's a of 1. That's where you start. That would be your difference. And then I thought,
say that again?
Because the first number isn't,
This?
it doesn't have the difference included in it, but the second
True.
one does.
Okay, that's true.
So I just did that in reverse. I subtracted that and from the 0 and then divided by the 5. And then, I don't know.
I think you got lucky. I know that would be, I can see that would be the same answer. Yeah. That wouldn't, yeah, that won't work. No, there's no reason that second one should equal 0. I mean, it luckily does this time. Yeah, unless I'm missing something. Why would that second one be 0?
No, I said it equal to 0 because the first term isn't affected by the common difference, by the d, but the second one is. So I did it in reverse.
So that means second one minus first one, though, equals the d. The d is the jump from the, not from 0 to the second one, but from the first one to the second one. You know what I mean? So anyway, we can talk about it later. I wouldn't rely on that. Let's see, number 25. So how many terms must be added in an arithmetic sequence whose first term is 10 and difference is 5 to obtain a sum of 4725. So we're saying, all right, the first term is 10, right? First term is 10, and the difference is 5. So they're going up by 5 every time. So this would be like 15, 20, 25, and I don't know what the last one is. And they all add up to be 4725. And what they're asking me is, how many terms? N equals what? Because n's the number of terms. How many terms to add up 10, 15, 20, 25, etc., and get a total of 4725? How are we going to do that? Well, they're adding them up, so we're going to certainly use the S sub n, which means the sum formula, which is n over 2, a1 plus an. And that sum is 4725, right? That's what the sum comes out to be. Good so far? N, that's what I'm trying to find. I don't know n. That's what they're asking me for. What is n? How many terms? A1 always means first term. An always means last term. N always means number of terms. So do I know the first term? Yeah, that's 10. Do I know the last term? No. I don't know the last term. So what do I do whenever I don't know something? Go use the other formula. An is a1 plus n minus 1d, so it's kind of the same thing. That's how we always do that. So now here we go. A1 always means, remember, first term. What's the first term? Still 10. N, I don't know. That's the whole problem I'm trying to figure out. And D, what's the difference from term to term? 5. It's going up by 5 every time. So then distribute. And so A sub n is 10 plus 5n minus 5. 10 minus 5 is 5 plus 5n. So I found A sub n, bring it back, put it in there. 5 plus 5n in the place of A sub n. Everybody see that? Slow down there for a minute. See what I did there? So I wrote the S sub n formula. N over 2 times a1 plus an. I know a1. I don't know n. I know a1, and then A sub n, I went and did the A sub n formula and brought it back. So what now? Well, then now we have to solve this thing. That's not easily done. I'm going to, first off, whenever you got a fraction, a denominator, get rid of it. So multiply both sides of the equal sign by 2. It'll cancel here. 2 times 4725, I don't know.
9,450.
9450, thank you. And this is n, and then 10 plus 5 is 15 plus 5n. Everybody good there so far? So I multiplied by 2 on both sides, got rid of the fraction. You might wonder, a good question I get sometimes is, Mr. Aaron, don't we have to multiply the 2 in here also? No, whenever you have something outside of a fraction, whatever happens there will eventually carry in. So by just doing whatever's in the front, you've done the whole right side, really. So that's all you need to do with the 2, and it canceled right there. Okay, now I do need to distribute this in. So I get 15n plus 5n squared is 9450. Trying to solve for n, getting closer. Can I go to a fresh screen? This is the, trying to wrap up problem 25 here. And what is it? 9450 is 15n plus 5n squared. Okay, so how do I solve that for n?
Subtract.
Yeah, whenever we have n squared, you know what to do, right? Jump this over. Get a 0, put them in order, highest power to lowest, minus 9450, subtract it. I'm going to divide through by 5 to make the numbers easier. They're all divisible by 5. 0 over 5 is 0. It looks like nothing happened. N squared, 3n, and what's that? 1890. Okay, so we get to there. Now how do we finish solving that? The quadratic formula. Yeah, so then we go into the quadratic. Negative, it's a hard problem. Negative b plus minus square root of b squared minus 4ac all over 2a. A is 1, b is 3, c is negative 1890. You plug them in, you'll get a couple answers. I need to move on. ... You get one of the answers will be crazy. It'll be like a negative. You can't have a negative number of terms. Just throw it away. Remember, math isn't real, so sometimes it goes off in the never never land, and you just let it be, and then but you keep the real answer. All right. This one, or a form thereof, is usually on the next exam. Drury Lane Theater has 19 seats in the first row and 31 rows in all. Each successive row contains one additional seat. How many seats in the theater? So you get the idea, like front row has 19 seats. The next row is a little wider, 20 seats. Then as you go back, they each go up by 1 seat. You know, like a pyramid kind of thing. As you go back, and there's, in total, just go dot, dot, dot. So let me do that a little more thoroughly to the final one or whatever. And in total, 31 rows. So you get the picture? So 19 seats in the first row, then 20, 21, da, 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 da. 31 rows in all. What's the total number of seats? So if you wanted to count how many seats in that theater and you didn't want to go 1, 2, 3, 4 and hope you don't lose track somewhere, you would need the formulas we've been working with, huh? You would need to basically say, okay, I want to add up 19, 20, 21, dot, dot, dot. I want to add up those numbers, don't I? So that's S sub n, because we're adding them. N over 2, A1 plus AN. It's the sum formula. I like to put this one on the test because I think it's just a real good application of what we're learning. All right, so what is n? What's the number of terms? 31. That's the n, right? The number of terms? There's 31 of them, huh? 31 rows. Every row is a number of seats. 31. A1 means first term. AN means last term. N again was number of terms. So what's the first term? 19. What's the last term? Nah, I don't know. So what do I do when I don't know? Go use the other formula, huh? Same kind of thing. So go over here, use the A sub n, A1 plus n minus 1d. So can I get it with that? Get this out of the way a little bit. So we say, yeah, AN is A1, which is still 19, first term, plus n minus 1d. What's the difference from term to term? 1. It's only going up by 1 seat every time. Oh, and we know n. Yeah, I know n too. I'm not used to knowing n. 31. So I know everything there. So 19 plus 30 times 1. 19 plus 30, 49. The last row has 49 seats. There it is. Hit the buttons. 31 over 2 times, what's that, 50 and 20 be 70. 2 take away 68. So 31 over 2 times 68. I'm getting 1054. 1,054 seats in the Drury Lane Theater. So there we go. Good application on that one. All right. We